When you hear economics, many of you might think of market analysis, macroeconomic forecasting, or pricing models. However, economics, particularly behavioral economics, is making revolutionary contributions to digital service design itself. This is because behavioral economics scientifically uncovers human decision-making processes and behavioral patterns, allowing for more effective service design when applied. In fact, many globally successful digital services incorporate insights from behavioral economics. Today, based on Stanford University professor Susan Athey's paper and the Harvard Business Review article I co-authored, I'll introduce 6 roles economists play in digital service design, along with examples corresponding to each role. These aren't mere theories but insights based on cutting-edge empirical research and field experiments. I'll share outcomes from innovative projects conducted by economists worldwide, presenting the latest applications of behavioral economics in digital service design and the practical lessons learned. Professor Susan Athey proposes 6 important roles economists play in digital service design. Product designer. Designing digital services that address social challenges. Market designer. Designing efficient and fair rules for markets and platforms. Process designer. Designing innovation decision-making and experimental processes. Empirical analysis designer. Designing methodologies for data analysis and causal inference. Outcome measures designer. Designing indicators that measure social impact. Complex experiment designer. Designing sophisticated experiments considering network effects and long-term impacts. These 6 roles deliver highly practical value in digital service development. Let's examine each role with specific examples. Product designer. First is the role of product designer. As product designers, economists design digital services that solve social challenges. This requires not just technical implementation but design based on a fundamental understanding of human behavior. Professor Susan Athey introduces an interesting program called Dare IT in Poland. This digital service supports women entering the IT industry. Unlike conventional vocational training, this program was designed based on economic analysis. Labor market analysis revealed that IT companies prioritize demonstrated practical skills. Based on this insight, Dare IT developed a portfolio-based learning program, where women complete 6 mini-projects over 12 weeks to visualize their practical abilities. This approach, which demonstrates practical skills rather than theoretical knowledge, improved participants' IT industry employment rate by 42%. Another example is a nurse decision support app in Cameroon. This tablet application was developed to help nurses advise women about contraception methods. In the conventional decision-making process, nurses present all options at once. In contrast, this app suggests the optimal contraception method for each woman and introduces other options gradually based on patient interest. This design change alone increased the adoption rate of long-acting reversible contraceptives by approximately 3 times. This is a good example of how design that considers individual needs and behavioral characteristics can have a significant impact. Additionally, the Uber Eats Japan delivery partner safety checklist I was involved in designing is another service design based on behavioral economics principles. By providing nudges at the optimal timing, right before starting delivery, it effectively promotes safe behavior. Market designer. The second role is market designer. This involves designing market and platform rules and algorithms, especially important in digital platforms with many users. One fascinating example from Professor Athey's research is Kiva, a microfinance platform. Kiva provides loans to small entrepreneurs in developing countries. And the research team discovered that borrowers' profile photos significantly influenced funding decisions. Specifically, photos showing smiling faces, appropriate brightness, and professional impressions increased the probability of receiving loans. However, an important issue emerges here. These favorable photo characteristics correlate with demographic attributes like gender and ethnicity. This creates an efficiency equity trade-off. Algorithms that simply prioritize attractive photos might increase funding success rates, efficiency, but could disadvantage specific demographic groups, equity concerns. The research demonstrated what algorithm design could optimize the balance between efficiency and equity. Furthermore, it showed that guiding all borrowers on how to create effective profile photos could improve overall funding success rates. Another example is price nudge optimization on PayPal's donation platform. The research examined how changing default recommended donation amounts on donation sites affects giving behavior. The study revealed a trade-off: setting lower recommended amounts increased participation rates but decreased average donation amounts, while higher settings did the opposite. Additionally, it demonstrated that a targeting strategy displaying optimal recommended amounts based on user characteristics, like past donation history, could improve both participation rates and average amounts. This is a classic example of behavioral economics application in market design. Process designer. The third role is process designer. This involves designing innovation decision-making processes and experimental operations. For the educational app Stones 2 Milestones in India, an experiment was conducted to test contest-based incentives for developing children's reading habits. What's unique is the design allowed for estimating causal effects of habit formation, including peer influence, such as spillover effects, by randomizing contest participation at the school level. The experiment results confirmed that not only did reading volume increase during the contest period, but reading habits continued after the contest ended. This demonstrates that appropriately designed incentives contribute not only to temporary behavioral changes but also to long-term habit formation. Many digital services, including Match Group, which provides matching apps, have institutionalized the safety by design process. Safety by design integrates safety considerations into the service development process, building a system where service design and safety feature development occur in parallel. This enables enhanced safety without slowing development speed. Empirical Analysis Designer. The fourth role is Empirical Analysis Designer. This involves designing data analysis and causal inference methods. For the DARE IT program mentioned earlier, analysis design was also important. Typically, the effectiveness of job support programs is measured through surveys, but response rates decline over time. To address this, they adopted a design that automatically collected public LinkedIn profiles and tracked employment status over 12 months. This method enabled long-term effect measurement unaffected by declining response rates. The Media Literacy Education Project in Kenya also employed innovative analysis design. This project delivered educational materials on how to identify fake news to middle school students and measured its effectiveness. As an analytical design innovation, the project measured not only actual misinformation sharing behavior on social media, but also responses to hypothetical news articles. Specifically, participants were shown multiple news articles and asked questions like, "Would you share this news with friends?" and "Do you find this news reliable?" to objectively evaluate media literacy skills. This analysis design revealed that program participants significantly reduced their probability of sharing misinformation on social media. Outcome Measures Designer. The fifth role is Outcome Measures Designer. This involves designing KPIs, key performance indicators that measure social impact. In educational apps, measuring engagement is crucial. In the Stones 2 Milestones case, they designed a single indicator that could capture learning habit formation by weighted averaging multiple indicators such as clicks, completion numbers, difficulty levels, from children's reading data. The "Are you sure?" feature in matching apps like Tinder is another interesting example. This feature detects inappropriate messages using AI and prompts users to reconsider before sending. After implementing this feature, inappropriate messages decreased by 84% in the matching app Plenty of Fish. The importance lies in designing indicators that capture actual behavioral changes rather than mere satisfaction surveys. Outcome measure design was also important in the PayPal charitable giving platform case. Two indicators can be considered for measuring the success of donation sites: total donation amount and donation participation rate. However, these are often in a trade-off relationship. Economists visualize this situation as a possibility frontier, clearly illustrating how different suggested donation amounts affect these indicators. Furthermore, they demonstrated that targeting strategies based on user characteristics like past donation history could expand this frontier. By explicitly addressing trade-offs between multiple indicators in this way, more informed design decisions become possible, allowing PayPal to choose the balance that best aligns with their strategic goals. Complex Experiment Designer. Finally, the Complex Experiment Designer. This role involves designing sophisticated experiments considering network effects, spillovers, and personalization. The Agricultural Advisory Service experiment in India offers a fascinating example of complex experimental design. Researchers tested 91 different time slots to determine when farmers were most likely to answer calls providing agricultural advice. This was particularly challenging given bandwidth constraints that limited how many calls could be made simultaneously. Using an iterative experimental approach, they discovered significant differences in optimal calling times between female and male farmers. A finding with important implications for service delivery. This experiment demonstrates how sophisticated design can uncover nuanced patterns in user behavior that might otherwise remain hidden. The anti-misinformation experiment on Facebook Messenger in Nigeria and Kenya is another example of complex experimentation. This experiment compared multiple intervention methods to counter health-related fake news, such as vaccine misinformation. What's notable is the experimental design, which adopted a multi-armed bandit reinforcement learning approach. This method optimizes allocation by learning in real time which of many intervention methods are most effective. Results identified a simple nudge, prompting users to consider accuracy before sharing information, as particularly effective. The innovation of this experimental design lies in efficiently identifying optimal interventions. Using bandit algorithms, where traditional fixed A/B tests would require enormous sample sizes to compare more than 10 intervention methods. The design also allowed for analyzing effect differences across different countries and cultural backgrounds. As we've seen, economists can play diverse roles in digital service design. Particularly, behavioral economics insights enable product design based on understanding users' decision-making and behavioral patterns. Importantly, these roles complement each other. For example, designing appropriate outcome measures enables better experiments, leading to service improvements. Also, solid process design facilitates continuous improvement cycles. The examples introduced today demonstrate how behavioral economics can be a powerful tool in digital service design. Strategic design choices grounded in human behavioral principles can catalyze significant behavioral changes, even when the modifications appear subtle to users. Let me share some practical tips for those involved in digital service development. First, start by understanding users' behavioral patterns and decision-making biases. Grasping basic behavioral economics concepts, present bias, social norms, default effects, etc., enables more effective design. Next, create mechanisms for hypothesis testing. Even on a small scale, incorporating experimental approaches and conducting continuous data-based improvements is important. Don't forget to measure effects using appropriate indicators. Also, always be conscious of the balance between efficiency and equity. Particularly when implementing algorithm-based personalization, there's potential to unintentionally disadvantage specific groups. It's important to consider bias and fairness. Finally, incorporate the safety by design concept. By positioning safety as core to the design process rather than as an afterthought check, more sustainable innovation becomes possible. The 6 roles discussed today don't function independently but demonstrate their true value by working together. Digital service design incorporating behavioral economics insights holds potential for creating more user-centered, better services. Please consider incorporating these perspectives into your projects as well. If you found this video helpful, please let me know with a like. For practical solutions using behavioral economics, don't miss the next video by subscribing to our channel. Catch new episodes twice a month, on the 2nd and 4th Friday at 6 p.m. Japan time.